चव्हाण सर, गुड इव्हनिंग. तुम्हाला होस्ट केलंय.
तर मला काय हे शेअर करायला लागेल ना माझं स्क्रीन.
हां, तुम्ही स्क्रीन शेअर करा. तुम्ही होस्ट आहात. रेकॉर्डिंग ऑलरेडी चालू आहे.
हां हां.
ओके.
आता फक्त शेअर 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 एकच
खाली
मिनिट.
खाली सर वरती असं ॲरो असेल शेअर नावाचा.
हो, तो क्लिक केला त्याच्यात
हां,
माझा
मग आता तुम्ही
माझा स्क्रीन दिसायला पाहिजे. त्याच्यावर दिसला. तुम्हाला माझा स्क्रीन दिसतोय का?
येतोय सर. आली. येस.
न्यू अँड रिन्युएबल
हो,
एनर्जी
हो.
सोर्सेस. ठीक आहे
थोडंसं झूम
मॅडम.
करा सर याला. हां, चालेल.
हां, झूम करतो.
हो, चालेल. सर मग मी लीव्ह करते.
चालेल मॅडम. आणि नंतर मला फक्त क्लोज करायचं नाही, बाकी काही नाही.
हां, फक्त तुम्ही क्लोज करा. एंड करा मीटिंग. काहीच करायचं नाही बाकी.
ओके ओके मॅडम.
ओके. चालेल.
थँक्यू.
थँक्यू.
Only two students have attended, I think, Suprita and Anuja Mahale. Hello.
Good evening.
Good evening. Good evening. Since
Good
the
evening.
good evening, both of you. The videos are off, so though I can't judge whether you are there or not.
We are here, sir.
Sure. Should we wait for another 5 minutes?
Sure, sir. That's fine.
Yeah. By 5:20 or 22, we'll start.
Okay, sir.
If nobody comes, two of you are there. So if I ask to respond, at least one of you should respond so that I will know that you are hearing what I am telling to you.
Sure, sir.
Yes, sir.
If you have got your books with you, if hard copy is there, you can open to page number 263. Or if it is soft copy on your laptop, you go to page number 301 of book number 1. So that the same page will be visible to, it will be before you, which I am showing on the screen. Okay, I think we should begin because this particular chapter is the longest one. It contains 28 pages. And basically, the purpose of this particular chapter, New and Renewable Energy Sources, is to clear your concepts about the energy sources, their technology in brief, and with respect to its efficiency levels or the reasons why the efficiencies are less or more, what are the constraints. That's a general type of. On this chapter, you will hardly find any big question, not 10 or 20 mark questions on this chapter. If you go to the previous exam papers, test papers or solved papers, you will find about 3 to 4 marks multiple choice questions are based on this chapter. So you have to be very particular when you read this. You don't expect big examples or problems to be solved, not for even 5 marks, but there will be short notes related to a particular energy source, its efficiency. The short notes will be having 5 marks approximately. And in addition, in the first section of MCQ, out of 50 MCQs, you may find 3 to 4 MCQs based on the materials in this particular chapter number 11. So let us start. Since it is basically a conceptual clearance chapter, we will discuss the concepts. Whatever is readable and you can read through, you can understand. I will not spend much time on that. I will be more interested in explaining the things which are not very clear when you read these pages, right? So, fundamentals of solar energy. What is solar energy? You all more or less know. The purpose of, exploiting this particular energy source is basically to avoid the carbon use or hydrocarbon burning while generating heat. What heat energy we get from the solar rays is environment friendly. That means it doesn't pollute the environment any further. But solar energy has got its one drawback, that it is very widespread. No? The quantity of solar light or the energy falling on the Earth's surface is spread over a very large area. And this spread over energy intensity is so low that as it is, it cannot be used. You will have to collect it, concentrate it somewhere, and then raise the temperature of the medium you want to heat. Right? Again, solar spectrum is of different wavelengths of light. Ultraviolet, higher wavelengths, lower wavelengths, carrying different type of heat components into it. So therefore, when you are designing a solar cell, you are not able to collect all this solar energy in different wavelengths into that solar cell. Therefore, efficiency of a solar cell converting sunlight into another form of energy, whether it is heat energy or whether it is a light energy or photovoltaic energy, is limited. Remember, solar cell efficiencies are ranging in the range of 10 to 15% or 15 to 18%. Even in most highly efficient cell, it will not exceed 20%. That is why the collection of solar energy converting into power requires a larger surfaces because their conversion efficiency is so low. Then let us understand two definitions. One is solar constant. What is solar constant? When sun is there in the sky, it is giving light not only to Earth, but all the solar planets in the solar system. We have learned that. In our solar system, there are 9 planets or 10 planets, whatever, it's immaterial. So solar light reaching to that planet, including the planet Earth, is varying in intensity depending on the distance of that planet from the sun. So our planet is receiving certain intensity of solar light, and that intensity is about 1368 watts per square meter. This is constant for the entire earth whenever the sunlight is falling, but where it is falling? At the outer limit of our atmosphere. That means where the atmosphere is there above this earth, at that end it is 1368. But when it actually reaches to the ground, it has to come through a cloud cover or the gaseous surroundings in the atmosphere, stratosphere, and these of different kilometer heights. These covers all around the earth. So sun's light is penetrating through these gaseous and air covers into the on the surface of the plant. The intensity that is finally falling on the earth's surface is called solar constant. There is a difference between, not solar constant. Solar constant is 1368 falling on the atmosphere top side, and solar insolation is the word used for whatever solar intensity or energy falling on the earth's surface. Now this average value that is falling on the earth's surface is about 342 watts per square meter. In a MCQ, they may ask any of these two questions. What is the solar constant value or the solar insolation value? Now, solar light has got two powers in it, two energy forms. One is thermal energy. When you extend your hand, a bare hand into sunlight, you get a burning sensation. Why? Because the sunlight falling on your hand is having the heat into it. That heat gives your hand a burning sensation, right? But if you are not in the sun, you are sitting inside the room and sunlight is outside, still your room is full of light. Now, in your room, there is no direct sunlight. But how is the room illuminated? Because of the photovoltaic effect of the sunlight, this photo energy. So these two energy forms can be harnessed and used for different purposes. Solar thermal energy, which is direct heat, can be collected heat only, not light. Heat can be collected, and this collected heat can be used for water heating purposes. Now, whenever you want to collect something on a surface, you have to use something flat, no? You will try to get the larger coverage area on which the solar light is falling. So, solar water heating system, when you want to heat the water directly for solar, we are using it on the roof of our building, water heating system. What it contains? A flat plate collector, a water inside a flat tube in a spread over surface absorbs the solar heat energy and the water gets heated. Now, in single absorption, water may not raise the temperature to the desired extent. So, same water is circulated, and it is circulated by its own temperature differences. That means you will give cold water from the bottom, it will receive heat till it goes to the top, that is high. Again, it is recirculated through another tube, and finally, the water going outside your flat tube collector is having a temperature about 50 to 60 degrees easily. For household purposes, 50 to 60 degrees water is very good enough, because we don't want to generate steam there. No, we want only hot water. Generally, you remember these flat tube collectors can raise the water temperatures to about 50, 60, 65 degrees centigrade. Now, this water is used in the hot water form itself. It is not converted into steam. Right. This is one. The second type of heat collector is the evacuated tube collector, they say. This is the picture of it if you look at the screen. Here, no, this picture is flat tube collector and evacuated is here. See, this is the construction which we should understand. If you see the end view and the elevation, in end view, it is very clarified. There is one tube inside which allows the water to enter from the center tube. This tube is opening into a enclosed tube. So in the annular space all around the center tube, the water comes back. It goes through the center tube, comes back all around the same tube and comes back. Now in this travel from this end to the outlet end, this middle tube is covered with a heat absorbing metal, or what we can say the layer, heat absorbing paint or some synthetic layer. This layer absorbs whatever is the sunlight coming, and the outer tube is a vacuum tube. It is sealed at both ends. There is no air inside. And since it is vacuum, what is the much more advantage is the hot water in this, and this is the evacuated tube, it is moving. The heat does not travel by convection. Convection means touching the metal to metal or any two surfaces touching, and the heat flows from one surface to another. But if two surfaces in between there is a vacuum, heat cannot transfer by convection. It transfers by radiation. So the outside ray, sun's heat, will go to the inner tube. Because of the absorbent layer, it gets absorbed and impart the heat to the inner water, but it cannot come back. Whatever radiation small it will come, but the loss will be very minimum. So the efficiency of this type of evacuated tube heat collector is much more. You can reach outlet temperatures of 150 degrees centigrade, more than twice what the flat tube collector. No, this is a flat tube collector, this one. So efficiency of this is less. It can raise the temperature 50 to 60 degrees, whereas this type of tube arrangement gives you 150 degrees. Now, this difference of 50 degrees, 60 degrees or 150 will be prominent when you go to industry. In a industry where hot bath of water is required for many reasons, sometimes it is quenching, sometimes it is annealing function. They have to dip their hot parts into the cold water at a certain temperature, and they have to maintain the temperature of that hot bath water to certain degrees. They are using gas burners or other type of heat and spending money on that, creating CO2. As a energy auditor, I will suggest you put this type of heat collectors on the roof of the factory and reach a water level of 150 degrees centigrade temperature. Their bath temperature requirement is hardly 120. So 150 is a good temperature for them. They can totally eliminate the use of, say, gas burners or other diesel fire systems and all that. They can remove that system and go for a changeover this thing. From this point of view, a energy auditor should know which are the clean system which can save the purpose of the industry, different thing. Now, another way of collecting the solar heat on much concentrated level. That means reaching the temperatures of, say, 500 degrees, 600 degrees centigrade, which is not possible by evacuated tubes or the flat tubes. There you remember in childhood you used to burn a paper by putting a glass and collecting the solar light into a point. The point is falling on the paper and the paper starts burning. That is nothing but the concentrating the solar radiation heat at a one particular way to increase the temperatures. Same thing is used here when a solar power plant based on the heat, and when it is based on heat, it is called solar thermal power plant. Thermal heat. Anything related with the heat is thermal. Okay. So here is the sun god here. The sun rays are falling on mirrors, reflectors they are called. The reflector is of concave size and its center is somewhere at a distance. This can be adjusted always. We learned that in physics experiments. So this concentrating instrument has a center at the top of a tower, and this tower is coated with absorbent materials here. It's like a water tank which is circular on top of the tower. This container of water or tank is heated by the concentrated sunlight. Now, there is not only one, there is the entire field, acres and acres of land having the angle of that reflector in such a way that all the area heat spread over on the 1 acre of land, 2 acres of land, and it will concentrate only on this tank from all sides. Naturally, the temperature in the tank will reach very high. This high temperature, if you use here as a heating fluid water, Water has one drawback. Water starts boiling at 100 degrees centigrade. So whatever heat you give to the water, temperature will remain only 100, because any further heat added to the water used for converting the water into steam. You take example in your kitchen also. In a pot, you put in water and you increase the flame. It will start boiling. If you put a temperature thermometer there, it will be 100 always, but over a period, the heat will evaporate that water into steam, right? But here we have to concentrate the solar heat to higher temperature, say 1000 degrees, 900 degrees. So you need to change the temperature, which I mean the medium, which will remain in liquid state even at the temperatures of 506 degrees centigrade. So here we are using molten salt. The reason for using molten salt is molten salt remains in liquid state even at 288 degrees centigrade or more, up to say 560. So this is the ideal situation. You put the molten salt there, heat it to say 600, use that heat for converting water into steam. See the composition here. The concentration is here on this tank. The hot will go to the tank, storage tank, hot salt. This hot is circulated through a heat exchanger. Heat exchanger is the heat transfer between a water and this hot water. The heat exchanger takes place. This incoming water instantly gets converted into steam. The steam goes to the turbine. Then after doing work in turbine, it comes back reheated, goes to next turbine, and finally condense, again goes back to the exchanger, where it receives the heat, again gets converted. It's a closed cycle of water. It is steam here, going, reheating, condensing, condensing into form of water. The water again gets heated and good goes to steam. This is a closed cycle. All molten salt is also a closed circuit. This is cold salt at 283. It goes to the tank, gets heated, hot goes to this tank, gets circulated, exchanged through, then it becomes cold because it releases all its surplus heat, coming back to 283 or 280 degrees centigrade, goes back to the cold tank, again pumped back here. So this is a binary cycle, two cycles. One is water cycle, another is the salt cycle. So by this methodology, what we are doing is the steam is driving this generator. This generator is creating electricity and given to the grid. You got the concept. Now, if you have got any difficulty, you can always talk in between. I am not disturbed at all. Okay. All the details are given here. See, sunlight is concentrated, directed to a large field of heliostats, that is mirrors, to a receiver on tall tower. Molten salt, heated salt, molten salt, and this thing. Conceptually, it is better. Molten salt is a mixture of 60% sodium nitrate and 40% potassium nitrate. It is not the potassium chloride which we eat as a salt. That has a different composition. It is preferred as it provides an efficient low cost medium to store thermal energy, and it is non-flammable and non-toxic. It's a safe medium. That is why it is used. So in many times MCQ they may ask why the salt is used as a medium. Then there is another method of concentrating the solar heat. What is that? It is much simpler than the salt. It doesn't involve any salt. What they do, you see the reflectors here. It's a parabolic reflector. Means what? Suppose, I will just to clear your concept. If you have a plastic water pipe, 4-inch size, 8-inch size, or a very large plastic pipe having a size of say 4 feet diameter, 5 feet diameter. If you cut it in exactly the half, you will find two troughs, two halves generated. If it is a long pipe, there will be a parabolic structure is generated. Right. Now this parabolic structure has somewhere this center point, Kendra Bindu. Now that center point is receiving all the reflected sunlight concentrated into that point. So if the trough is parabolic and running lengthwise, the same center will also be running. There will be running center. That means everywhere in this red line, there will be intense heat concentrated from these parabolic surfaces. Now, if I put a water pipelines exactly in the center, the water in the pipeline will continuously receive highest heat temperatures from these parabolic reflectors as it was given to the water tank on the tower. So instead of raising a tower, what I will do, I will lay a length of kilometers of these parabolic structures in straight lines all over the field, 10 acres, 15 acres land, and run this pipeline through the center, collect all such concentrated water, which is very hot. And the magic is at this end, the water will enter these tubes as a water, which is ambient temperature. But by the time it comes out, it is already a steam. It has received so much heat, much more than the 100 degrees centigrade required for boiling, and any further heat continuously heating this water, converting into steam. This steam can directly be given to turbine or through a thermal tank, storage tanks it can be given, and then these generators are generating the power. Okay. So when you want to generate power, you need a higher scale on which you have to collect the solar heat. The higher scale collection is easier with this trough technology, parabolic trough collectors. And wherever there are solar thermal plants, they are preferring this method rather than using salt and creating a tower and so many mirrors operating on that, right? There are some pilot plants already operating on this system also, but this is a popular system and many thermal plants are used on this. Then comes the light component in solars. One type of energy we have used it. Second type of energy is no water required, no steam, no medium in between. You design a silicon material cell in such a way that solar's incidence or solar heat or light that is falling on it due to spectrum length of that particular light, the solar silicon material in the cell gets disintegrated into positive and negative electrons. And we know that if there is a positive and negative electron, it will develop a electronic circuit between plus and minus. That means you have a potential difference between 2 points. This potential difference, if you put through a resistance, you will get a light or you will get the power. If you put number of such cells, for example, one cell gives you only 0.5 watt. If there are 100, you will get 5 kW or say 5000 then 5 kW that you can work out with units. So if you put number of cells into a rectangular panel, it is called solar panel. Individual part in that solar panel is a solar cell. So number of solar cell connected in series will increase the voltage and thereby more the number of solar panels you use, more the land covered by it will give you power in megawatts. Now, here no heat is used. The energy what you are getting is through the photovoltaic energy from the sun's rays. You got the concept. In solar, the sunlight, there are two energies. One is giving heat. Here, another is the photovoltaic. Now, we cannot differentiate these two energies. We are using it for two purposes, right? But the solar light falling on the cell, photo cell, also contains heat, isn't it? So the panels get heated because they are in the sunlight, they get heated. But since they are in open, the natural ambient air currents keep the temperature within the ambient temperature range. There is no damage to that. Otherwise, if it is beyond that, it will be damaging to this thing. Only defect on this is the dust, falling atmospheric dust, and some shades of the trees, or say cloud cover in the atmosphere in rainy season, where the intensity of light falling on the photocells is obstructed, then only the light output or the power output from these cells is reduced. Okay. Now these cells, as I said, are not efficient. They are hardly 10 to 15 or maximum 20% efficiency of conversion from solar photovoltaic to electric light is very poor. Second disadvantage, so long as the sun god is there in the sky, they will generate. If he goes out of horizon, the generation stops. Again, if the solar light is falling straight at right angles to the solar panel, it will give maximum production. If it is at angle, suppose in the morning when the sun comes up from the horizon, right up to 30 degrees above horizon, the rays falling on your panels are slanting at an angle of 5 degrees, 10 degrees, 15 degrees. When it becomes 90 degree, it is maximum, but it starts generating from say 15 to 20 degree angle. It will continue to generate till the angle is on the western side 15 to 20 degrees from the horizon. So this time gap in between the solar production will continue is called a solar window. Remember these names because there will be questions. What is solar window and all that thing? Solar window is normally considered as 9 in the morning to 3 in the afternoon. That's the solar window. All this thing what I am telling you is there written in this chapter. You read through it, remember it, and reproduce it in the paper when you are asked. Right. Now, once we know the trick, how to generate power from solar light, we want to commercialize it, isn't it? We have to use it for a grid connected solar system. You are already aware what is electric grid, right? What is electric grid? Number of power generators located at geographically different situations, producing power, and then through transmission, they are supplying the power into a network. And this network is connected to different factories, industries, clients, customers. They are taking the power. You imagine a water tank full of water. Input water is coming to the tank and the output water is going to different purposes, agriculture, drinking water and all that. Similarly for electricity, the grid is a container. It doesn't contain the power. It doesn't store the power. But the power comes and power goes. Remember, it's a dynamic system. Electricity cannot be stored. So, whatever is generated is to be consumed, or rather, whatever is consumed is to be generated. This balance is maintained by keeping watch on the frequency level of that particular grid. That, of course, will come in different system. You are all energy students. So, grid connected systems, when you talk about, what you have to do is you have to understand that grid is alternating circuit, AC current, alternating current, whereas the generated power by PV, the photovoltaic, is a direct current. So if you want to connect it to the grid, you will have to use a inverter in between. The inverter will convert the DC power into AC power and then connect it. So number of small generators of DC power are to be connected to the grid, and then it can be a part of total electricity generation. Okay. Now here, he has given you calculation of how much solar energy is converted into electrical energy in photovoltaic cell. Well, you go through the example, very simple. The answer is interested. Efficiency for this cell is 15.6%, much below the 20%. 20% of course is for new advanced technology cells, but otherwise conventional cells are 10 to 15%. Now, building integrated structure, these are all innovation. What is building integrated? Somebody said if the cells, that means the solar cells or the solar panels, if they are designed with very hard glass surface, then you can create a roof of that panels only. There is no need of putting separate roof. So your cost of the roof of the building can be saved. The roof itself can be a power generating or the solar cell roof. That is building integrated structures. Okay, so far solar. Now let us go to wind. Wind, the conceptually, see how wind is created. Look at the picture here. Is it visible to you? Hello?
Yes, sir.
Yeah. If you have got any difficulty, you can stop me in between. Okay, no problem. So you see the picture. This is the earth, and then in between is the equator. This is equator. Equator, up above the equator is northern hemisphere. Below is the southern hemisphere. India comes under northern hemisphere. We are just above the equator. Right? Now, above the equator and below the equator, the location of the solar panel for collection of maximum solar heat will be different. If you put a panel in northern hemisphere, because the sun travels imaginary line on which the sun travels from east to west, his rays will be caught up when your panels are facing to the sun, that means towards south. So you will find all solar panels in our country are facing south just to collect the maximum sunlight. If your country is here below the equator, all the solar panels will face to north to collect maximum solar from the sun which is traveling on this route. Fine. Secondly, when sun moves, rather it's an imaginary movement, actually earth moves, not the sun. So earth's surface as it comes in the shadow or the sunlight area of the sun, how earth travels? Earth goes from west to east, moves. That is why we think that sun is coming from east. No, we are going towards sun. Sun is stationary. So this movement of the earth creates different hot surfaces on the earth. Right? Now this area is under sunlight, it moves. So this area will come under sunlight. Again it moves. This comes under this. Like that, it goes on. There is a temperature difference between the sun's earth crust. Because here it's 12 o'clock in the afternoon, highest point. Here it is morning, it is evening, and so on, whatever is going on. So this creates a movement of wind or the air. I will not say wind. It is the air nearest to the surface, hot surface of the earth will try to go up. The upper cool air will try to come down. So a air circulation because of temperature differences all over the earth goes on. But this is not creating wind. Wind is created by the earth motion. Earth moves at a certain speed. The entire periphery of the earth, so many kilometers, it completes in 24 hours. So that's the speed. Now, this speed of the earth creates whirls, or we can say chakrivadal, no, like this. This round circles different of the earth created into the atmosphere that creates a wind. And then we say northern winds, southern winds. When we say the rain comes from the south, isn't it? The cloud is carried by the wind. So this wind is created. This is the description what I have told you. You can read through. The earth rotation creates wind. This is known as different scientific names. Rotation of earth creates a force known as Coriolis force. This Coriolis force is swirling action on the winds because of earth rotation, right? This causes series of wind circulation in both northern and southern latitude as shown here. So if there is MCQ small, how wind is generated? Because of the earth's rotation, right? Okay. Now let us see the further effects of that. Variability in wind speed and its effect. Wind speed is not uniform at all locations. Even on the same location, it is varying. Sometimes it is velocity is high velocity, sometimes it is a poor velocity. There are n number of atmospheric factors for that. But if we take a air velocity survey at different locations, you will find that air speeds are different. But what we have selected, wind speeds versus power generation suitability. See, even a small wind velocity will rotate your small turbine. It's not commercially collectible, so we'll leave that. We cut off, as we say, solar. Solar, is there no sunlight in the morning? Yes, it is. But it is so low intensity that it will not generate power. So we have selected a solar window, say morning 9 to afternoon 3 o'clock. Likewise, in different speeds of wind, we have selected a window like this. This 4 miles per kilometer per second or equivalent to converted into kilometer range, it is 15 kilometer per hour. If this is the velocity, no good for power generation. We will not collect this. As you go on increasing the wind velocity, rather naturally it increases, you start generating power. At 18, it may be a cut-in speed, poor. 22 moderate velocity, 25 good velocity, and 29 is a excellent velocity at which your windmill will run faster, generate more power. How it generates? Because when wind blows, it creates a thrust, and that thrust is rotating the turbine blades. That's the simple principle on this. Now, naturally, as engineer, you can tell me, if the blade is longer and more larger area is covered by the windmill, will it not increase the capacity? Yes. Larger the turbine blade radius, it will rotate into a very large area of circle, and wind flowing right angle to this surface will generate more thrust on this. So you can have a large capacity windmill, maybe 1 megawatt, 2 megawatt. Nowadays they are going for 7 to 8 megawatt windmill, single unit. But you know what is the difficulty from engineer's point of view? If you make this blade larger, longer, it will touch the earth, isn't it? So in order to avoid the blade touching the earth, you will have to increase the height of the tower. And then it goes on, goes on. It becomes impracticable to raise a height beyond certain value. And therefore, increasing the blade length beyond a certain limit is not possible. Theoretically, yes. Practically, no. So what is the thumb rule? The radius of this blade, single blade, from hub to this tip should be 2/3 of the tower. 1/3 of the tower should be left as a clearance from the ground level. This is the thumb rule, remember. So if you want a tower of say 30 meters, you can have a blade of 20 meters only. 10 meters, that is one third of tower, you will have to leave for the clearances. This is one. Then the components of the top hub. Remember, this is called hub, the center portion. 1 minute. I will just start the charger. Yeah. This center portion, which is located on the top of the tower, is called Nestle. This Nestle contains what? The breakup is here in this diagram. This is a tower height. This is the blade, one blade, two blade, third blade. And in the center, the rotor. This rotor is a primary or a low speed shaft, low speed rotor. You know, even when they are generating full capacity of say 1 megawatt, the rotor revolution is hardly 5 to 7 revolutions. This slowly, if you look at the windmill at the top of a mountain, you will find they are rotating slowly. But this slow rotation is converted through a gearbox to a 3000 RPM revolutions per minute in a smaller shaft. This gear wheel has more teeth, this smaller has lesser teeth. The gear ratio will increase the speed from 5 to 3000, right? Very large gearbox. And this is connected to a generator which will generate power. These are basic. What is that? Slow speed shaft, gearbox, and generator. These are three things which are essentially located here. Other, of course, control, then voltage controllers, connectors, that kind of panels. Then, what another important factor is this Nestle or this portion, the entire thing, it rotates on the column. It rotates. Why? Sometimes the wind changes direction. Earlier it was right angle to this, then later on it starts blowing at an angle. Then this windmill should self change the position facing right angle to the wind. Why? Because right angle to the wind directly increases the thrust and more power is generated. So this change in the direction of the blade is achieved by U drive or YAW, your motor. YAW, your motor, electric motor. This electric motor gets the sensing from this wind vane. This wind will sense in which direction the wind is blowing, and accordingly it will give signal for the motor. The motor with the help of this gearbox will slowly rotate the turbine and make it at right angles. Okay, these are some basic things we should understand. So as I explained, it's a low speed shaft, high speed shaft, gearbox and generator. Disc brake. Why disc brake? You can imagine a condition when there is a typhoon or a very, what they call it, a very high velocity of wind, वादळ आलं. Then what will happen? The wind speeds will go beyond the control, natural wind, and the turbine will start rotating at tremendous speeds. It will damage the entire gearbox, generator, everything. To avoid that, there is a one safety mechanism. These blades can also rotate here in the base. Right now, to collect the maximum thrust, they are right angle to the wind. If the thrust is more, they become parallel to the wind. So they cannot have any thrust from the wind. It will not rotate. It will stop rotating. When this is in this position, it will receive the thrust. If it turns like this, parallel to the wind force, it will stop rotating. And this rotation is finally stopped with the brake motor. These are just safety mechanisms into that. So I'm sure you are now aware. Disc brakes, yaw control means the rotational control on that. operating characteristics of the turbine. You remember only these three terminologies. Cut-in speed. This is a minimum speed at which a wind turbine can reliably produce usable power. This is known as cut-in speed, which is generally around 5 meters per second wind speed. As we have seen in this table, earlier table, no? Wind speeds we have seen at which the generating gas 5. See, this is 5, which is poor, but this is sufficient to overcome the inertia of the rotor and start the windmill. This speed is called the cut-in speed. The stopped machine starts rotating, so it is cut-in speed. They will ask you a question on cut-in speed also possible. And this speed, if you look at this diagram, it starts increasing at the wind speed increases. 4, then 8, 12, 16, 20. These are the wind speeds in meters per second. They start increasing, the power starts generating more and more. This is the peak power at which it is. Any wind speed going beyond the peak power, the blades will stop rotating. They will become parallel to the wind force and power control is 0. It will not generate any power beyond this. So this is the graph area in which the wind is generating the power. Okay. This is the characteristic. So rated speed is at which it is achieved at rated wind speed. Most wind turbines are designed to generate maximum power at a fixed wind speed. Here they are generating maximum power. So this speed, which is say around 27, we can say, this machine is used to maximize to use 27 meters per second. Any speed beyond that, well, it will stop generating. The cutout speed is called furling speed. That means the speed at which the horizontal bed will go right angle. Right? It will stop generating. This is called cutout. Machine we say no, normally even general terms, cut in, cut out. Cut-in speed is the minimum at which the machine starts rotating. Rated it is generating full, and cutout means the speed beyond the limits provided, and therefore it stops generating power. Now let us look at Bed's not ends, Bed's limit. It is impossible for the blades of a wind turbine to be 100% efficient, since some of the wind energy must pass through the blades to make the turbine turn. Now, air flowing over the blades and through the rotor area makes a wind turbine function. The wind turbine extracts energy by slowing down the wind, isn't it? When you are stopping something, when generating power, the wind velocity, when strikes your blade, it rotates the blade, but it reduces the wind velocity for that particular location. The theoretical maximum amount of energy in the wind that can be collected by a wind turbine is approximately 59%. This value is known as Bed's limit. Remember, what is Bed's limit? The maximum amount, theoretical maximum amount of energy the wind can be collected by the wind turbines. Considering the bed's limit and efficiency losses through the generator gear will result in only about 15 to 25% of the wind energy being converted into useful power. We have seen the solar heat power or solar light power converted into electricity has a efficiency below 20%, in the range of 10 to 15%. Same applies to wind also. Whatever force the wind is thrusting on your wind turbine, it is converted into the conversion losses are about 70%. And then rest are the frictional losses. So finally, the power generated is hardly 15 to 25% of the wind energy that is converted into useful power. Now then there are different definitions. You can go through all these definitions. What is rotor efficiency? what is the coefficient of performance, power availability from wind turbine, kinetic energy from wind is so much, mass of the wind is so much, and the power output. Normally, they don't ask a question or a numerical on this formula, but it is better to know conceptually how it is arrived. The speciality of this formula you will find. See, I will only explain the formula. In the formula, power generated in watts is a multiplication of 0.5 is coefficient. This nu is the density of air. A is the cross sectional of the wind intercepted by the wind turbine in square meter. You can calculate area of a circle when you know the radius or a diameter, right? So the area of the blade rotation circle is m square. Coefficient of performance of blade, it is given by the manufacturer. Generator efficiency is also given. Gearbox efficiency is also given. What is the relation between them, where V is the wind speed in meters per second? If you look at the formula, you will find this is constant. Wind velocity, I mean density is constant. Area we are varying by increasing the blade length. Both these efficiencies are constant. And then what is V? That is the wind speed. So power is proportionate to cube of the velocity of the wind. Suppose the velocity of the wind doubles. It was earlier 5 meters, it went to 10 meters per second. How much power will be affected? 3 cube times. That means 2 cube is 8. So earlier velocity, if doubled, the power will be 8 times more. Remember this always. It is in the cube form. Increase in velocity, increase in power is cube form. If it is 1, it will remain so, but if it is 2, it goes to 8 times. That kind. So this will be a MCQ again for a small this thing. Let's not be confused about it. So here it is. For example, consider a wind turbine with 6-meter diameter rotor, coefficient of performance so much, generator efficiency, everything is given. Wind speed is also given. They say calculate the power. Just use this formula and do it. If at all, in a very rare chance, but if at all the problem comes on this numerical, it will be for 5 marks maximum. And there also, your answer will be judged not on the final answer you are taking out, but whether you have used correct formula, whether you have filled in the values which are given at a correct place. You may create a mistake in calculation, that is okay. But otherwise, this procedural correctness will give you 4 marks out of 5. So be sure that the formulas which you are using are correct. Now let us come to capacity factor. This is another factor which is very particular, and we should understand the concept of this particular factor. What is capacity factor? It is kWh produced upon 8760 multiplied by nameplate rating of the turbine in kW. I will give you a simple example. I have an industry of the capacity of producing plastic buckets, 1000 buckets per week. Okay, I have purchased the machinery, everything, and I am guaranteed given that 1000 plastic buckets per week will be manufactured. But when I take a review, I find that average, instead of 1000, I have manufactured only 920 buckets. Fine. So what percent of capacity I have used for that plant? It's 920 upon 1000. That's the percentage at which I have used the capacity. Similarly, a windmill is guaranteed to give you so much generation, so many kWh in a specific period, per day, per hour, per second, whatever you say. Time limit is same because it's a ratio. So in whatever time period you assume the kWh is produced, divided by what is the actual number of kWh you should have produced as per capacity. 8760, you know what is that? These are the clock hours in a year. That is 24 hours into 365 days in a year gives you this value, 8760. So hours into the nameplate capacity, that should have been the generation if this factor is 100%. But it is not so in practice. We generate less than the production capacity of the machine, and therefore this capacity utilization factor or capacity factor it is called is important to compare the technologies. I will give a simple example. This factor for solar is hardly 17 to 18%. This same factor for wind is hardly less than 25%, again, more or less same. But this factor for a coal-based power generation, it's as high as 95%. That means if you have a power plant based on coal, supposed to generate 210 megawatt per unit, this 210 will give you consistent performance for the whole year up to the full capacity. So if I want constant power at a fixed rating, I will prefer a technology which gives me a stable load rather than depending on wind or solar, such type of unreliable energy. That is one factor why the renewable power is not so very popular commercially. Okay. This you can read through, nothing long. Then the next form of energy is biomass energy. What is biomass? Simply speaking, anything that is growing naturally is a biomass, right? Anything, any green mass, any tree, any type of flora into that particular location. Now, biomass is made up of hydrocarbons and carbons. You know, everything. Every biomass can be burned. If you burn it, it releases the heat energy. What we want is energy. Heat energy from solar we are extracting. The thrust energy from the wind we are extracting. The hydropower energy of gravity, water falling from height, we are collecting. Similarly, heat in any form can be converted into electricity. Now, if we get heat from biomass, it can also be converted into energy. What you need is a technology suitably you can burn the biofuel, release the heat, use the boilers which can use biomass as a fuel. Likewise, you have used the boilers which are suitable for, say, waste, municipal waste, we are using. You must have studied FBC boilers in your boiler chapter. So these type of boilers can use this. Now, how to use this biomass? See, solid biomass includes coconut shells, rice husks, bagasse, wood waste, oil, seed cakes, de-oiled bran. Biomass of low bulk densities are processed into pellets. If it is a shavings of wood, no, lakdi bhussa, it can be compressed and converted into pellets, small capsules, you can say, wood capsules, and they can be burned in place of coal into a boiler. Second use of collecting the energy is to create mass, I mean गॅसिफिकेशन ऑफ मास. आपण म्हणतो ना सडवणे कुजवणे त्यातनं जो गॅस इव्हॉल्व्ह होतो, द गॅस इव्हॉल्विंग बिकॉज ऑफ द degradation of the biomass. That gas also contains hydrocarbons. It has a heat value and it can be used as a gas to burn and create heat energy. Now this gasification is done in different ways. Is a partial combustion of biomass takes place in the temperatures of this window. Yeah. The products of combustion are combustible gases like carbon monoxide, hydrogen, traces of methane. Mota moti, you must remember the elemental formulas. Carbon monoxide, CO. Hydrogen is H2. Methane is CH4. Right? Because on these elemental values, their heat value depends on that. Elemental value of heat value of hydrogen, of carbon, right? These are different, and depending on that, The burning release of heat, intense or low, is depending on that. The production of these gases is by reaction of water vapor, carbon dioxide through a glowing layer of charcoals. The key to gasifier design is to create conditions such as biomass is reduced to a charcoal and charcoal is converted at suitable temperature to produce CO and H2. Both are combustible gases. They can be used for fuel. They will release the heat for that. So you remember the figure, try to see the segments on which drying zone, pyrolysis zone, combustion zone, reduction zone, ash removal. This is a gasifier unit. It's simple. It's a description like any other equipment description you go through. You try to just understand conceptually what is the purpose, what are the exothermic and reduction reaction. What is the exothermic? Which gives out heat. Therm, as I said, therm is heat. So exothermic, that gives out heat, the reaction. That means this C plus O2, when carbon burns and becomes carbon oxide, so we call it carbon dioxide, two elements of oxygen, one carbon and two oxygen for a carbon dioxide. In doing so, this is a burning process in which the oxidation takes place. It releases heat. Since it releases heat, it is exothermic. Similarly, when hydrogen burns, it, it reacts with the oxygen. It forms water, but in this process, it releases tremendous heat. It's a high intensity exothermic process. When there are reactions where heat is absorbed, that means to complete the reaction, you have to heat it. It's called endothermic. Remember the words. Exothermic gives out heat. Endothermic absorbs the heat into that. Or it's called reduction, carbon and H2 reduction process. Now this is a water gas. This is a methane gas. Methane is CH4. Remember the formulas, because some few formulas, not much, but you will have to keep them reminding. Then typical producer gas combination. What is a producer gas? Again, let us not confuse. What is producer gas? It is a series of reaction involving carbon and hydrogen and oxygen. So the formation of producer gas is methane, CH4 and CO2. Together, the mixture of these two is called producer gas. Remember the formula when they ask you whether the producer gas is a composition of these two. These are examples. Go through. It's a very simple one. Then biomethanation of biogas. Anaerobic process. Don't go into the chemical formulas and maybe you find them complicated, but you read through, you should know the concept, how the biogas is generated. You must have come across in rural India, the biogas units are put in many villages. What is bio? Bio is the slurry of cattle dung, water, whatever, the bioenergy. It's mixed into a homogeneous mixture and then it is fed here. When it is going through the fermentation process, a gas is evolved. This gas is passing through two filters and the gas being lighter than other elements, it goes up by gravity, gets collected. The up collection is in the tank and the slurry goes here. This collected gas, which is coming by velocity or the low density, is then collected and then through a pipeline wall, it is used for different purpose. Remember, the biogas generated here is not under pressure. It moves because it's a gaseous form. It separates from the solid slurry and then goes up, gets collected at the top and then used. Now, this biogas has got multiple functions. It can be used as a fuel. It can be used in a chemical factory to disintegrate and separate out the hydrocarbons from it. Ethanol is created, produced from the fermentation of molasses, a byproduct in sugar manufacturing. Or it can be again manufactured from any carbohydrate, starch, sugar, or cellulose. For example, sugar beet, sweet corn, lingocellulide materials like straw, wood paste, wood waste, all these are biomaterials which can be converted into biogas or ethanol. Ethanol, you must have heard that the flexible fuel vehicles which run on mixture of gasoline use up to 85% ethanol. The same characteristic of a petrol or say a gasoline, which is the another form of petrol, you can substitute with 85% of ethanol. Right now, government is allowing the mixing of ethanol into petrol as high as 20%, not more than that. They started experimenting with 5%, 10%, 15%. Now it is permitted, but people are not using 20%. Right now it is 15% that you can use, thereby reducing the demand of petrol. Biodiesel is a good alternative for diesel. The most economical way of producing biodiesel is by transesterification of extracted oil, jatropha seed oil. Jatropha is planted, it's a verb, it's a plant. That plant, the seeds of this plant can be extracted and can be converted into diesel by a particular process called biodiesel. It can be used as an additive to reduce vehicle emissions. Typically, 20% reduction is possible if you mix the biodiesel. What is this process here? Sun's energy goes to jatropha seeds. The seeds oil is extracted here. This oil goes as a protein residue and the oil in liquid form goes in making of biodiesel production. This biodiesel is used for multiple purposes. Glycerin production or other cosmetics and other industry, they are using biodiesel. And it also goes to the diesel pumps which are used for fueling the diesel vehicles. But the exhaust of a biodiesel also is CO2. You cannot eliminate carbon by using biodiesel. Only thing, you are reducing the cost of imported petroleum which we have to pay. Another source which we'll look at is the hydropower. Hydropower is the simplest way of generating power by using the gravity of the earth. Take a simple case, you put a water at elevated position, one small turbine at bottom, keep the distance in between, release the water through a pipe to the rotating turbine. It will continue to rotate so long as the water is flowing from the pipe and impinging on the turbine blades. As simple as that. But what is the reliability? So long as there is water in the upper reservoir from which it is coming to the turbine. If the water dries up, well, your generation stops. That's the concept, isn't it? Therefore, when the rain god is happy with us, we can have ample hydropower. If it is a drought condition, rain god is unhappy, no rains, then all the big dams go dry. You cannot generate power because whatever water is there in the dam, you have to use it for drinking purposes, for irrigation purposes. You can't use that water for power generation, right? Okay. Depending on the size of the water reservoir, we can generate the size of the power generated. See, for more than 25 megawatts, it's a large hydro. We are talking about the small hydro sizes, not the large, because hydro can be 700 megawatt, 1000 megawatt. Our own Koina is about 2000 megawatt it can generate, right? But here we are talking about the renewable energy source as a small hydro unit. So under this small category, it starts from 25. So 25 and above are large. Small KW, this is 2000 means 1 megawatt, 2 megawatt, 225 megawatt feeding the grid is a small hydro. Mini hydro is 100 kW to 2 megawatt. Micro hydro is from 11 kW to 100 kW, and pico hydro from a few hundred watts to 10 kW. Why so much classification? Because depending on the water source, if you want to put a hydro on a perennial flowing river, the river having all the 12 months it is flowing, it has sufficient water. Well, you can impound the river, stop the water, create a reservoir, and do the power generation. But you can spend the entire water by putting a larger machine, and remaining 10 months of the year it will go dry. It should not happen. So depending on different, their purposes are also different. Suppose there is a cluster of 10 villages into rural India. A small river is flowing in their area or in their fields. They can have a small turbine. Just put up a 11 kW turbine. That 11 kW turbine is sufficient to give at this the lighting power, not for machinery. Lighting power to all the 11 villages. They can feed it. So depending on the requirement, a energy manager or energy auditor should give advice to them. Yes, you can have a small plant here, put your own grid and you will have almost free of cost power, because the capital cost is given by the government under different subsidies. So there are methodologies. Look at this. The river is originating, that means coming from the mountains, and flowing as per the contour of the land. Right? This again I will shift. This contour, and it goes down, 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 and it goes down. This is the main flow. Many times people are agitating for stopping the river. If you propose, okay, I will have a very large dam here and stop the water that is coming through here, nobody will allow. So what you say, okay, we will have a win-win situation. We will have a small barrage here, not a dam, barrage. This barrage will create some small height in water and divert part of the water of the river through these, and then ultimately coming back to the river. So you can say, oh, I'm not disturbing your river. I'm not taking out any water. Water will go through the river only. But I will not stop the entire water. Part of the water will be coming, creating a reservoir here, artificial. And from that height, right up to river bed, you lay a pipeline. This pipeline called penstock will carry water and rotate this small turbine here. This turbine is connected to the generator, which is generating power. The outlet of the water turbine goes to the river bed and it flows as usual. This type of arrangement is known as run-of-the-river micro hydro scheme. You can have a small power plant, 1 megawatt or say 2 megawatt here, which is sufficient to feed the region all around in the rural sector. It may be for agriculture use, it may be for drinking water schemes, it may be for lighting purposes in the village. This is the run of the river. Remember the name, run of the river. What is the other method? As we have seen, stop the river, build a big dam, create a reservoir, and then use the same methodology. Here, he has given you how to calculate how much power can be generated. Power is generated because there is a gravity difference or the height difference between two positions, that water and the turbine. How much weight of water is released through how much height? That is the gravity force into number of cubic meters flow and the height between them, whether it is 10 meter, 20 meter, 30 meter. A multiplication of that will give you the power. See how much power generation potential is available in a run-of river mini hydro plant for a flow of 20 liters per second with a head of 12 meters. Assume power system efficiency as 60%. Here he has multiplied by 0.6. Efficiency is 60%. So with this example, we know what is this 9.81? It's the gravity. Gravitational force, 9.81. Efficiency is 60%. 20 meters, rather liters, is the flow mass which is flowing, and 12 meters is the height. That will give you multiplication 1.4 kW. Got it? Now, another resource, that is fuel cell, which is using hydrogen gas as a fuel. The concept of fuel cell, look here. We are going through number of resources, energy resources, which are renewable. Hydrogen is also renewable. When hydrogen is in a fuel, it has a tendency act as a anode and cathode catalyst and forms a electronic circuit in between. Depending on the quality of hydrogen and the flow of hydrogen mixed with oxygen, it gives a power circuit, a small compact power circuit. It's called fuel cell or hydrogen cell. The potential difference between the anode and cathode gives you the voltage available. You put number of cells, you will get higher voltages, higher current values. The description you can go through. How the operation of fuel cell takes place? It consists of two catalyst-coated electrodes surrounding an electrolyte. In an anode, other is cathode. The process begins when hydrogen molecules enter the anode. The catalyst coating separates hydrogens, negatively charged electrons from the positively charged, and they create two circuits. Right? If you read, you will understand. Nothing complicated about it. So, how many types of such fuel cell can be made? The types of fuel cells: proton exchange membrane fuel cell. Don't go much into the complicated names. Only understand there are anode hydrogen, cathode oxygen. This is one type. Anode methanol, cathode oxygen, another type. Or hydrogen and oxygen, again, the anode and cathode. This is third type. The advantages, disadvantages here, I don't think they will ask you in the exam, but still reading is always better so that you have some rudimentary idea. What is that limited to? Fifth type is synthesis gas, that is hydrogen and carbon monoxide with another cathode is oxygen, and then this is synthesis gas and oxygen carbon diode, that is another. So these are some technological details giving you number of way a hydrogen cell can be used for supplying power. What are the application of fuel cells where it can be used? The type of fuel cells used is decided by application in which it is used. Since fuel cells are capable of producing power anywhere in the range of 1 watt to 10 megawatt, they can be applied to almost any application that requires power. That is why they are thinking of running the trucks, heavy vehicles, by using the hydrogen as a fuel cell, thereby creating a very clean ambience. Because when hydrogen burns, when it oxidizes, it forms H2O, that is water vapor. In the exhaust pipe, only the water vapor will come, no carbon into that, because there is no hydrocarbon to burn. Like that. These are very useful inventions. Only thing, commercially, they are to be made viable. The technology, the pilot projects, they are doing R&D on this particular. The high power fuel cells, 1 kW to 100 kW range fuel cell, can be used to power vehicles. The megawatt range fuel cell can be used to convert energy for distributed power uses, different things. Energy from waste, this is another source. Municipal waste or whatever is the throwaway debris, which were household people are throwing it on the street. This is a waste. This can be generated by two methods. One is composting, another is burning. By both these, say power generation from landfill gas. That means entire kuda, kachra, municipal waste, wet, dry, everything goes to a dumping site. For metropolitan cities, very large dumping site. Daily hundreds of tons of waste is being dumped there. And they create mountains and mountains of waste in that particular area. When it just integrate, no, because of the heat generated inside, a gas is created that is called landfill gas. What is it? It's the landfill gas. This is the kachra, all the dumping trucks are coming, putting it here. Now, this gas burning the trash heats up and the waste ash is taken away. The gas is used in a turbine and used for power generation. This is a schematic diagram. It's not very technically correct. Another method of expanding, if this is a dumping ground, a perforated pipes are embedded inside. Pipes with number of holes. So that whatever gas is released because of the heat and waste degradation, the gas will enter these pipes because it is lighter than the solid weight. It will travel through, get collected into this tank. From this tank, it is screened and cleaned, then used in the gas turbine. It rotates this shaft of the generator, and this generator is in supplying power to the grid. This is power generation from landfill gas. Power generation from any heat value material can be generated, as you know. We collect heat from any source, whether it is solar or whether it is wood burning or it is waste burning, whether it is biomass burning, anything. We are in need of heat. That heat is provided this landfill gas. This is the generation from waste. What is the next way of generating? Is the wave energy. Wave energy means what? The tide that is coming into the sea. Wind blowing on the surface of sea creates tides, waves, different. Some waves are very huge, some are smaller, but all waves have a thrust in them. The waves coming to the shore are thrusting something. They are bringing the debris and anything into that. You try to stop the wind, wave, you will be thrown away. Even when we stand on the seashore, water hardly reaching your, say, knee, will have a thrust to fall you down. That kind of energy is there. And particularly in typhoons, in high tides, the waves coming to the seashore has got tremendous thrust in them. Can we extract that thrust and rotate our turbines, thereby generating power? That was the conceptual idea. And therefore, to practice this tidal energy, wave energy, what they have done, suppose they create a structure like this. What is that? This is a pakka concrete chamber, black, and it has an opening into the seawater. Below the surface, the wave force in a tidal wave comes inside. Since it cannot go outside, it will thrust and try to raise up because it is forcing. The thrust is coming from the seaside. When it forces, this aperture is closed. Only this is open. Through this, it will go up because of this particular force. When it goes up, when water goes up in this chamber, the air goes out because it's an enclosed volume. When the tide goes back, no, it's a continuous movement of seawater, coming, going, coming, going. So coming wave will go through this hole, rotate the turbine here, it will pass through this and air will go out. When it goes back, it will create a vacuum here. The air comes in, the water goes back. When the air is coming in with a force in the vacuum, it will rotate the turbine in reverse direction. but it will rotate. So water will rotate it from this side, air will rotate it from this side. This cycle of rotating the turbine one way, then other way, one way and the other way will continuously move and generate the power here. That's the basic idea. Conceptually, this is the idea and this is given the appropriate name of tidal energy. Second way of using the wave energy. It's a this is a shore and this is the main sea body. The wave coming from the sea goes through this turbine. No pipe, nothing. You just create a very solid foundation, allow the sea to enter through this tunnel. While moving, it will impact the blades of the turbine, it will rotate, generate power. When it goes this side, after some time, it goes back to the sea because that is the natural movement of the tidal waves. So while coming, it will generate. Again, while going back, it will generate. See, this is the going back. Tide going out, tide coming in. So continuously, these turbines will be rotating and generating the power. Now, the beauty here is once you install it, it is for life. There is no extra expenditure on this. Only whatever the maintenance expenses will be there, but no input costs, only the capital cost for installation. So it is the cheapest way of doing it. And this is a perpetual motion. All the time, in all the months, in all the seasons, there is no stoppage of wave movement in a sea. And India has got such a large seashore all around that if we put enough strong installations on this, tidal power will be such a simple and less costly, most economical method of generating power. It doesn't involve any CO2 burning, no heat, no CO2 going to the atmosphere, right? This way. Conceptually, you should know this. Then next resource is the geothermal. When you go below the earth's surface, if you dig well deep enough, you will find the temperature of the strata increases by some degrees. And you go deeper, the more and more temperature will be there. So the core of the earth is in layers, no? The innermost core is called a magna. This magna, remember the word magna. When this magna, which is in a liquid form, it's a very, very high temperature magna. If there is one volcano broke up through the surface, if this magna comes out on the surface, we call it lava, LAVA. It is called lava. But the basic core is called as a magna, right? Remember the distinction between that. So, can we use the heat in the magna for our purpose? Because we want heat from any source. So, this heat source, what we'll do? We will dig a well into the as deep a strata as possible. Put one high pressure pipe through this well, spread the water in this area, put another hole or well which will collect the steam. That means the water will be instantly converted into steam because of this heat. The steam will be channelized and coming out of this well. So two wells are necessary. One is injecting well, second is the steam collecting well. This steam, which is full of dirt, debris, stone particles, can be filtered and the clean steam can be used for rotating a turbine. Then the water condensed out of the condensed tip can re-injected and a closed circuit can be used for generating power. This is the circuit. Suppose this is strata, geothermal then. What we are doing is we are injecting the water from this side. Number of holes to this pipe. In this strata, the water is spread through the fissures, gets evaporated, gets converted into steam. This steam is collected by this pipe, sent to the turbine, and then use the turbine through this and used. So this is a steam power plant. It's called dry because it's a clean steam. When it is not, when the steam is partially wet or when the dryness fraction is less, then it has to go through a filter arrangement, brine and steel, and only the steam will go to the turbine. That's the only mechanical difference between. But the basic principle is to collect the heat from the magna into the water. The water gets converted into steam. That steam is used for power generation into the turbine. Now, there is some again modification when they use double circuit. Binary cycle means what? When then two fluids are used. One fluid is water. When water cannot be used because the water has the boiling point of 100, you can't raise the temperature of water beyond 100. Therefore, you use another chemical which can be in liquid form for 600 degrees centigrade, and then that 600 degrees liquid can be going through the exchange with water, then water can be heated. These are just refining the processes, but the main methodology is same. Extract the heat from this. Now here, find out the conversion efficiency of gasifier of 20 kg of wood. These are different examples. These are solved examples based on what is the source or resource of renewable energy which you can gainfully. Basically, mota moti as a energy auditor, you will have to, just a minute, I will close the window, making a lot of noise. There they may ask you a comparative question. Which renewable source can have a better conversion efficiency from heat to electricity or thrust to electricity? That kind, and may give you a small example based on any one of the renewable sources. Here you can go through these examples. This is only one. And then we come to the end. But my thrust, particularly telling you that you already know the basic equations, you know the methodology, you can do the calculations. You read and try to remember the technical terms for that. But particularly for this chapter, not much important. Don't spend a lot of energy on this. Basic things which I have explained, you remember those things. Mostly it will be MCQs. Try MCQs. And my thumb rule is, if you are not sure which alternative is correct, don't leave it blank. You mark is the nearest approximation you remember. Oh, ye ho sakta hai. Then there you mark it. Worst can happen, it will go wrong. But if you keep it blank, still it is going wrong. So there is a chance that 50% possibility, 40% possibility, it can be correct. Second simple rule is, out of 50 MCQs which you are trying on this book, if you can score 40, 10 you can go wrong. Even if you score 40 correctly, what remains is only 35 marks you have to obtain from remaining 100 mark question paper. Out of 150, you have to get only 75. So give thrust on MCQs, particularly small, like I will give an example. Here it is. Let us go through these questions at the end of chapter. Which among the following raw materials is used for biodiesel production? Unless you have read the book, no, we know it is the corn, isn't it? Biodiesel production. So corn is one, B is correct. The non-renewable energy sources. What statement is correct? Non-renewable energy sources, remember the wording, can be plugged in and recharged? No, because they are non-renewable. Will not work for new applications? No, it is not correct. Will eventually run out? Yes, because non-renewable means having a fixed quantity, reserve like coal, petroleum, oil, gas, fixed quantities. So eventually they will be used if we consume them more. So B is the correct answer. The rotor blade starts to rotate at बोलो, cut in speed. Cut in, starting the turbine. Cut out, going out of service. So they will start rotating at cut in speed. If wind speed doubles, energy output of the wind energy will be 8 times. We have seen V cube, 2 into 2 into 2, that will be 8. Cube of 2 is 8. So the power will increase 8 times if the wind velocity increases double time. What is solar constant? But first you remember what is constant. Constant is the solar incidence falling on the top of the atmosphere of the earth, not on the ground. Right? What is that solar constant? We have seen it there, no? It is 1368. If you go back to the page, you have a book, you can go to that particular page and find out. A solar cell is made up of silicon. Correct answer is silicon. The molten material mixed with gases in the metal of earth is called what? Just now I talked to you. Inside it is a magna. If it comes out of volcano and spreads on the surface of the earth, we call it lava. But when they ask you molten material mixed with gases in the mantle of the earth is magna. What is wind? Which statement is correct? Wind is the product of temperature differences between atmosphere and stratosphere? No. Wind is the product of air pressure between atmosphere and solar rotation disparities? No. Wind is the movement of air caused by beating wings of the birds? No. Wind is air movement caused only by earth rotation. That's the D is the correct option. Typical efficiency of solar cell, 10 to 15%. We have seen that. It is never 25 or 50 or 75. Not that high. It is always the 10 to 15. Producer gas, it's only CO and CH4, carbon monoxide and methane. Right. So these are MCQs, 1 mark each. This type of may come. You can go through the past question papers of the last examinations. You will find 2 or 3 such MCQs based on renewable sources. Then short type questions. Normally they are not asked, but if at all they are asked for 5 marks, why solar cell efficiency is very low? I have explained that different wavelength of sunlight is there and the solar cell silicon material can convert only specific wavelengths. So it cannot convert the entire heat value or the light value into the sun's light. Therefore, it is very low. What capacity factor is in the wind turbine? We have seen it is hardly 19% or 18%. What is the basic requirements of tapping tidal energy? What is basic requirement? We should have civil structure suitable for using the force and using it through the turbines. That is the basic requirement. What is the beds limit? Go to the particular page in the book and find out. Why evacuate tube collector is more efficient than flat tube? Because through evacuation, through vacuum, there is no heat loss. So the inner tube which receives the sunlight through a coated tube keeps the heat inside. There is no going back that heat. Whereas in flat tube collector, heat is received and partly it goes back to the atmosphere. Right. And long type questions, if at all they ask, they will say, explain the operation fuel cell with a sketch, list and explain various components of typical wind turbine. We have explained, no, blade, the yaw motor, the low speed shaft, high speed shaft, the generator, then the wind directional, wings. These are, you explain briefly. If you can draw a diagram, nothing like it, and you will get the marks. So with this, we come to the end of our chapter. We still have 10 minutes. So if you have got any questions on any subject, you can ask me. It's open for discussion. Are you still there or you have already left? Hello?
Sir, we are here.
Yeah, you are there. So you can ask me the questions, or if there are no questions, yeah, let us say goodbye.
Sir,
You
just
can,
a question like these bifacial solar panels, is the efficiency more than the like normal photovoltaic panels or?
no, bifacials does not have more efficiency. What happens is the area exposure is double, isn't it?
Yes.
One face and the other face. So in the same frame of a panel, you have got double the area which will absorb sunlight. Right. But since bifacials are not at right angles to the sun's light, one face is at right angle, another in the shadow. Or if you put it vertical this side and this side, the solar light falling on these vertical panels is at an angle. It will not fall with full intensity. Therefore, even though the surface is double, the production is not double. Whereas the cost is double, almost. Only the metallic structure may be slightly different, but not proportionately. As you said, if we did bifacial, it will not increase the efficiency or the collection efficiency double. Albeit some percentage there will be higher because the surface area is double.
Okay, sir.
You can keep your videos on also when you are discussing so that I will know at least who is speaking. Akshay, you want to ask something? Akshay, are you there? I think he has left already. Okay, Suprita, you want to ask something?
No, sir, I'm good.
Okay. Okay, then we will call it a day. Thank you. Thank you for
Okay,
Thank you
attending.
so much,
you,
sir.
sir.
Thank you.
My only request is when you come for my lecture, if you at least go through the chapter which I am going to teach you, you will understand it better. You can have your genuine difficulties. Conceptually, if you have not understood anything while reading it, I will be happy to explain the concept and you will understand it better. Okay then, bye.
Sure, sir. Thank you.
Thank you, sir.
Thank you.